So now at the end of this mini tutorial, I just want to talk about particles. Particles, not dissolved substances, but particles. Let's have a look again at the next slide. So we essentially have similar distribution here. And what you can imagine that over time, you actually get a steady state distribution of your dissolved property. Okay, so just imagine that this one is the temperature field. And because you have advection and diffusion operating at the same time, you tend to get what we call steady state, a field that does no longer change. So just imagine that this one is still, although there is an input of water at the source, you actually virtually you don't see any changes in the distribution of the temperature. So, but now you add a particle, and this is what I've done here with the yellow star, and it's not a surprise in the end that you actually see the particle will not be subject to diffusion because you only have one particle, and all it can do, it can just follow the advection pathway. Okay, and I click on it and you see the advection. This is the advection pathway. It might wiggle around a little bit because it gets some random diffusive displacements, but this is what happens to particles, and particles can behave significantly different from the dissolved properties. Right? So that's the end of this tutorial, and it's important to know what is advection and diffusion, the difference, and to be able to derive the pathway of currents in the ocean interior from this principle.